Hello everyone, welcome to the day 29 of the training. Today I am going to discuss some more important questions asked in the interview rooms in the technical interviews of FPGA development or any hardware related role in the VLSI. In the VLSI domain, technical interviews mostly will be welcome to the experienced candidates, and as a fresher, don't get worried, have hands-on experience in the FPGA development boards and do some quite pretty projects and get familiar with the projects and writing Verlog HDL codes with test bench developments as well for the simulation. More the skills, more the talent, higher rate of selections and high success rate in getting interview calls. And with that being said, let us go to the interview questions. We have a technical interview questions like assume these questions will be asked in the interviewer sessions, and that questions can be like this: what is the difference? Let me take my pen. Okay. What is the difference between blocking and non-blocking assignment? We have discussed in the earlier sessions of Verlog HDL. In the blocking assignment, the behavior is next statement waits for the current statement to the complete before executing. So it depends on the next state. The current waits for the current state. So the output of that thing depends, and it happens sequentially. Blocking assignments means if you write a condition like if else or any other thing that occurs, every each line or each statement in the blocking assignment will be assigned in a sequential order and they will be executed in a sequence. Likewise, in non-blocking assignment, you can see that is a different scenario. It can operate parallelly. In the non-blocking assignment, you can see that can occur parallelly. That means the next statement doesn't wait for the current statement. I mean, if you have two statements, this statement is not depending on the previous statement, that present input that gives the input. So all the statements are individual of the operation, so they run parallelly in non-blocking assignment. So you can see that blocking assignment is equal to and non-blocking assignment is less than or equal to. So you can use, and in the blocking assignment, whatever the value of B is possessed, that can be equaled. I mean, that can be referred into the A at that current state. But in A less than or equal to B means setting A equal to the current value of B. Whatever might be the current value, you never know. Before this statement, you can see B can be 2, and before that B is equal to 1. Now current value is B is equal to 2, then A is equal to 2 now. That's what this assignment is called. Non-blocking assignment works parallelly and continue with the next statement. Okay, let us go to the next question. What are the inter-assignment delay and intra-assignment delays? For example, if you are giving some delay inside the procedural block like this, that is called inter-assignment delay. And intra-assignment delay is nothing but within the statement, if you use some delay statements like after 3 nanoseconds, #5 and #3 are nothing but after 3 nanoseconds. So inter-assignment delay of 5 time units, that's nothing but after 5 nanoseconds, and this #3 is after 3 nanoseconds. Don't get confused. Mostly this is to the deep understanding of Verlog HDL. You should know these things. What is a function? Function is a reusable block, a set of block that you are defining a function that can be used n number of times in the entire Verlog HDL code. Wherever you want this function to be run, that function you can do it. For example, function sum, you can directly use this word like a sum b or sum brackets a comma b, sum of a and b. Okay, you can say in that way. We are using the defined, user defined, and now it is a reusable block of code that performs a specific operation and returns a value. Functions can return a single value using a return statement. So like for the printing of the functioning value, in the function int add numbers. Add numbers is the thing that I have written in here, and init a and b. Int is nothing but integer. And what type of function you are writing? You are writing a integer function. The output should also be an integer. When you add two integers, the output should also be an integer. So in the matching of that output and input of this function, you have to mention the data type as well. Int is a data type, and return the value. What is the function operation? A plus b, operator a plus b, and function usage. You can see result is equal to some result, some other thing. Add numbers 3, 5. You see the result as 8. Got it? And now let us go to the what is a task. Task is a reusable block of code that performs specific operation but doesn't return a value. Tasks are not typically used for procedural code or operations that don't need a don't need to produce a result. I mean, tasks can be generally used in test bench simulations than in the actual design file. So for that, I can give you an example of the previous lectures in the task that we have written. Consider a FIFO, and you have seen the task called read task, write 16, read 16, and end read, end write task. These type of tasks we have written in the test bench simulation, that kind of thing. And some other example is like task print hello, display hello Verilog, end task, and usage initial begin print hello. You can see hello Verilog is printed. So what are you getting? You are getting a task to be begin here. So print hello is a task. Likewise, you can see we have written task write, and we have used that write write brackets mem of 0 we have written, right? Likewise mem of 0 taken to 6-bit hexadecimal FE semicolon brackets. Like this we can write in the task if you have mentioned task write. Okay, what are the flow control constructs in the Verlog HDL? It's nothing but whatever the procedural block involves a control statements in the loops, that loops are nothing but flow control constructs. They are if else loop, case loop. These two if else and case are nothing but synthesizable things. Synthesizable means whatever the code condition you write, that condition can be turned into a piece of hardware. That is the meaning of synthesizable blocks. If else and case, most important, you should know the difference. And what are the other flow control constructs? You have for loop, while loop, and repeat loop. These are non-synthesizable. So why these are non-synthesizable? Because in the FPGA development, Verlog HDL or VHDL description languages, these for loop, while loop, and repeat loops are used for repeating the instructions for number of times. So code to execute in each iteration. So that kind of instructions can be repeated. This is not like in the normal C programming. We use loops for printing the data or having the value incremented or decremented n number of times for getting the n number of results. So not this kind of thing. Okay, but in the Verlog or VHDL, that's a different scenario. For loop, while loop, and repeat loop are used for repetition of instructions or duplicate the instructions for number of times for different set of hardware designs inside the FPGA. That for that number of iterations, for that many number of iterations. Got it? So let us see the next question. What is the major difference between VHDL and Verlog HDL scripts? Yeah, Verlog HDL is case sensitive and VHDL is case insensitive. Like you can see in the VHDL, whatever case you have, whatever statements you write, whether it is a capital, alphanumeric, or small case letters, it doesn't bother. It isn't most seen in the VHDL with the syntax errors, but consists of user-defined functions and very strictly written in the VHDL. But Verlog HDL is case sensitive. All the things should be lowercase. You can't be very sure with the uppercase things, and if you make any uppercase statement or any nomenclature, that will be varied and you will produce a syntax error. Verlog HDL does follow the syntax similar to C programming. This is repeated number of times. Let us see the next question. What are the design entry methods available for the FPGA? In the beginning of our trainings, we have worked with Xilinx ISE, I mean Xilinx Vivado tool. By opening it, we have clicked on create new project. After creating new project, after that window, we have seen either to implement with RTL or either to implement with an IP integrator, or can we take an pre-existing file from the neighboring project teams in the real time, or we can consider the existing projects from the open source. Can we implement with the constraints file? So those are the different methodologies. What are all the methodologies? We can have the RTL files. RTL files are nothing but register transfer level language files, that is the architecture files that are written in VHDL or Verlog HDL. You can consider those input files like design sources. We will be adding design sources, right? You can start from that RTL file, or you can start with IP integrator. Like we have took microblaze processor, right? Microblaze processor, and what we have done in the IP integrator selection, we have selected the microblaze and we have generated the HDL wrapper such that we don't need to write Verlog HDL. In the larger designs, it is mostly used in generating the HDL wrappers, and it is not suggestible sometimes because you would never know how this design has been occurring, and if there is any debug, if you have good debugging skills, nothing matters. But if you are a fresher, it is better to have a balance in using IP integrator or creating RTL files with Verlog or VHDL descriptions. Post synthesis is nothing but already some pre-existing designs which have passed through the synthesis stage and ready for the implementation. You can take those design files and add it to your own design and use those blocks into your own design. So that kind of design entry methods are also available. So coming to the next question, what is the FPGA design flow? When you are applying for FPGA roles or hardware design roles in VLSI, you should be very familiar with what is the design flow of FPGA development and what is the ASIC design flow. So for that, FPGA design flow: specifications, design entry, functional simulation and behavioral simulation after this thing, and synthesis, implementation, static timing analysis, generating the bit stream, test and debug after generating the bit stream. And this test and debug can be done with two methods, VIO and ILA. Capture the signals in ILA, and VIO is to check the network issue like connecting issues, so that kind of issues. And this is the entire flow of FPGA design flow. We get the specifications, we make the design entry into the EDA tools, and we collect all the files, input files, like constraint files, all these files to be got into this. And functional simulation or behavioral simulation, that can be written with the RTL code. For example, you have developed a Verlog HDL file, design description file. You have to simulate it, run the simulation first, and after running the simulation, you can see, okay, this HDL language is properly written without any syntax errors. And then you have synthesis. You have to synthesize to realize the hardware logics from the description that you have made for the design. After synthesis, you can relate to implementation with place and route. Floor plan, or after place and route, you can have the optimized design as well. What the implementation does: translate to the mapping to the place and route to the optimization. After that, you have to check the timing simulation and also the functional simulation after the implementation. After this entire logics are connected, after the hardware is getting ready, that hardware to be verified in the simulation backgrounds in terms of timing analysis and also in the functionality verification. After that, your design is very good, and then generate a bit stream to upload into the FPGA. That is the flow. Okay, let us go to the next question. What is the significant use of comma, or, and hashtags? I mean star. Uh, in the always block declaration. In the earlier version of the Verlog modules, design or operator separates the input variables, whereas nowadays in the latest versions, comma and star are used as the same meaning to differentiate between the input variables. There is nothing much difference. See, earlier stages you have used operator called or, like this or, but nowadays current days comma and star can also be used for always at the rate of change of inputs. That's what a simple difference. This is asked generally to test whether you have worked across the versions of FPGA, and did you notice any significant changes in the Verlog HDL writings. So let us go to the next question. How Verlog simulator schedule events? Simulator is nothing but test bench simulation. What are the different steps of test bench simulations? Let us see. Verlog simulators use an event driven model where changes in signal values triggering events scheduled in a queue. So all these events are planned. Those will be executed in a sequence. That is what the queue means. Progressing through discrete time steps. For example, I will start at after 20 nanoseconds, and then after I will give after 5 nanoseconds, and now I am giving after every 10 nanoseconds. I am executing the conditions. These all things we have made in the test bench simulations. If you have referred to the previous lectures, you can see in the test bench simulation, you can always see the data processing or the input values that we give. That will be assigned for every 40 nanoseconds, 30 nanoseconds, or 10 nanoseconds at a regular point of interval of time. You can see the example as well here in the module process, test bench simulation, registers and clock. Initially clock is 0, always after 5 nanoseconds. This is one sequence, and after 10 nanoseconds, after 15 nanoseconds, you are telling something to the test bench simulation to do with the design file. So after 5 nanoseconds, clock should be 1. This is to enable the clock, because initial value of clock is 0, now new value is 1, so clock is enabled. Initial begin after 10 nanoseconds, then waiting for the 10 nanoseconds. I mean, we give the tick time scale 1 nanosecond and 10 picoseconds is considered, right? In the same way, dollar display for every for after 10 nanoseconds we have to display the output. After 15 nanoseconds, dollar display we have to display. Dollar finish to end the simulation. So at particular intervals of time, this schedule is planned. What is the difference between dollar display, dollar monitor, and dollar strobe? These are system tasks, and these system tasks have a very slight difference. Dollar display is used for on-demand output, only what output you want that to be desired, that to be displayed. Only that particular output should be displayed. Monitor is nothing but it displays everything. Automatically monitors and displays variable values when they change. For example, monitor we can involve dollar time as well. If we can give dollar time and whatever the value in the quotation that is to be printed, for every particular change of the value of the clock or of the input for the variable that we need to print, everything will be printed in a sequence. Dollar strobe is nothing but used to display a message at specific time during simulation. in the simulation, like you can use dollar strobe or dollar display. Mostly we can use dollar display without any ambiguity. Describe test bench and its structure. As we have understood the flow of the design, we can understand the test bench and its structure as well. We have written test bench because in the interview room, you should know the design description file. You have to write Verlog HDL design description. Also, you should be able to write test bench as well. So for that test bench, the test bench helps ensure your design works as expect before actually hardware is built. So mostly the test bench is used for simulating and verifying the actual design to not to ruin the hardware. That's what I have explained in the initial stage. And there are different stages: design under test, test bench module, and clock generation. I mean, when this test bench module should work at particular amount of clock, then you should be enabling the clock. So often includes creating a clock signal for the design. So this clock generation is also included in the test bench to simulate the clock of the entire design. And then it has input stimulus, like provides input values to the design under test, like our own design, primary design, to see how it responds. Okay. Assertions. Assertions is nothing that checks or conditions to verify the correct behavior. For the inputs and the outputs desired at the design stage, for those we need to give a conditions to verify the correct behavior. Just check this answer with your previous explanation in the test bench simulations that we made for the understanding of test bench simulations. And at the end, we need to monitor the output waveform. We have monitored the output waveform with initial begin. You have seen dollar dump file, right? Dump file, dollar dump file, dump where's. You have seen this kind of representation: initial, begin, and end. So this is nothing but monitoring. You should be mentioning all these 6 steps in the test bench and its structure. Okay. Now let us see the next question. What is the purpose of this system task, and give an example. System tasks in Verilog are special commands used during simulation for debugging and controlling the simulation process. Some of the system tasks are dollar display, dollar monitor, dollar strobe, dollar stop to stop the simulation, dollar finish to end the simulation immediately. Dollar stop is nothing but you can start from the beginning itself, beginning of the test bench simulation. But if you say dollar finish, there ends the matter. There will be no simulation after this. Dollar time is to print the time of the output whenever the output changes. If your output changes at 5 nanoseconds, your time will be printed at 5 nanosecond, and at regular intervals of the data changes, regular intervals of time changes. Okay, so that is it. And the next question is, what is net, reg, and wire data types? You might get some confusion between this. See an example code and understand. Here, wire is nothing but it continues connections between digital elements. Wire between two modules. Digital elements are nothing but between two modules or between two gates, or the input to the gate, input to the register, or input to the module. That is nothing but wire. Register is, it represents the storage elements or the output registers, like whatever the arrays of registers we have in the memory. That is nothing but a storage of 8 bits of data, for example. And net is nothing but generic term used for referring to the connections in the circuit. In the FPGA, if you have AND gate and you have OR gate, let us see, this can be a multiplexer, right? And OR gate is connected to the multiplexer, and this can be called as, generally called as net. So nets are nothing but representation. Okay, this element of logic and that another element of the logic are internally connected with a net. So that's a general term used mostly in the routing stage. Routing stage, nets are connected. So in the Xilinx Vivada itself, we have seen some highlight of the nets when after the implementation of the design. So next question, what is the difference between procedural and continuous assignment? Procedural assignments are like step-by-step instructions useful for things that happen over time, like in response to a clock. So it is like a sequence, one after the other, one after the other. But in the continuous assignments, describe connections that are always active, like saying two things are always equal. They are more like constant establishment among signals. So continuous assignment is like when there is a communication between two modules, there will be a constant establishment of communication signals between these two things in a order, describing connections that are always active. So it is always active, it is never switched off between the I mean that connection is not turned off, like saying two things are always equal, so they are internally connected always. Okay, that is today's session. If you have any other queries, or if you want to have some help in understanding this concept or any other stuck at point, please let me know. I'm here to help you. I will definitely reach out to you. Thank you so much. Happy learning.